Welcome to Climate Questions with Emma. I'm just your average college student trying to spread the word on climate change. So let's dive into that topic, huh? There is a long-standing myth that the current climate change we're facing is part of a cycle, and that's been going on for billions and billions of years. So we shouldn't worry about it, right? Well, let's talk about that.
First, I needed to find a few keywords that'll help us on our journey to better understanding the situation we are in today. So, what exactly is climate change? Climate change is a long-term change in the average weather patterns that define Earth's local, regional, and global climates. Local climate is the weather occurring in your immediate vicinity, like when you check your phone for the weather and it says it's going to rain. If it always rains in your area at that time of year, then it would fall under your regional climate. But the most important is global climate. This is the average long-term change in climate over the entire Earth, like changes in sea levels, melting glaciers, hotter than average summers, so on and so forth. Today's video, we are going to be focusing mainly on global climate, past, present, and future. Which leads us to our next key word, paleoclimate. Paleoclimate is basically the study of past climate to understand where our future is heading. You might recognize how scientists use tree rings or ice and sediment cores to measure past climate. However, these only go back so far and can only tell scientists so much. Now to confront the myth. Yes, our planet has gone through many cycles of heating and cooling. Each cycle affected the planet differently, but left devastating, long-lasting effects in its wake. The difference between these past cycles and today's global warming is time. Let's look at a few cycles to show the difference. First, let's look at a warming cycle. We are going to talk about the Paleocene, Eocene, thermal maximum, or PETM for short. Roughly 55 million years ago, thousands of pentagrams of CO2 was released into the atmosphere. Now, scientists aren't exactly sure of the root cause, but evidence shown in sediment cores shows the acidification of the ocean and had warmed it as a whole about 5 degrees Celsius. The ocean is a natural carbon sink, meaning it can absorb CO2 from the atmosphere, thus making it an essential element in regulating global temperatures. When CO2 dissolves, it reacts with water and forms calcium carbonate. This then settles on the ocean floor and becomes a buffer when the ocean dissolves too much CO2. That leads us into acidification. Acidification occurs when the ocean absorbs way too much CO2, and once it gets dissolved, excess hydrogen ions decrease its pH level, making the ocean more acidic. By using sediment cores, scientists can see that once you get to a certain depth, the decreased pH causes the calcium carbonate to dissolve, thus proving evidence of acidification. Once the calcium carbonate dissolves, it releases carbon into the ocean, allowing the excess hydrogen ions to pair with it, in turn making the ocean less acidic. The duration of the PETM took about 100,000 years to take full effect, and the devastating acidification took over 200,000 years for the planet to fully recover. Now let's switch gears and look at a cooling event. Roughly 20,000 years ago, the last glacial maximum, or LGM, covered most of the northern hemisphere in ice. This was due to orbital cycles, also known as the Milankovitch cycles. There are 3 important orbitals you need to know. First up is eccentricity. Basically, it means the Earth moves in an oval around the Sun. Now, the oval shape is important because it determines how long our seasons will last. When our planet is further away from the Sun, our seasons will become short and in turn cause more extreme weather like hotter summers and colder winters. It has an orbital cycle of 100,000 years. Next up is obliquity. This is about the Earth's tilt. This orbital can also greatly affect seasons on Earth. When the planet has a low tilt, it causes very weak seasons. It also allows ice to build back up on the poles. Whereas, if Earth has a strong tilt, it causes very strong seasons. It also inhibits ice growth. Obliquity has a 41,000-year cycle. Finally, let's talk about precision. As the Earth spins on an axle, it tends to wobble. This in turn affects specific hemispheres seasonally, making one more extreme than the other. This cycle has a 25,000-year orbital cycle. Note that all of these cycles take a very long time to cause extreme season conditions. Scientists speculate that these 3 cycles lined up to cause the planet's temperature to cool dramatically enough to cause the LGM. Now to address today's global warming. As shown, yes, there have been cycles of heating and cooling, so how is our current warming any different? Here's the deal. These all occurred naturally and took a very long time to really affect the planet. Whether it was the release of tons of CO2, which warmed the planet, or orbitals lining up to cool down the global temperature, these all happened naturally. What's not a part of this equation is humans. After the Industrial Revolution, humans have sped up this warming cycle. What originally took 100,000 years to warm the Earth for the PETM took us only 200 years. Yikes. This is not a normal cycle. This is caused by humans, not nature. The importance of paleoclimate comes into play because we can make a pretty good educated guess at what will happen to our climate for the future. Let's look at the PTM. Huge amounts of CO2 were released into the environment over the course of 100,000 years. This dramatically raised Earth's global temperature, causing massive extinction to many aquatic species. Sound familiar? Today, we can see our coral reefs bleaching, glaciers melting, and seasons becoming more intense like in the past. However, there is always hope. Just because the past global climate left devastating effects on our planet doesn't mean this has to be our future. The planet's global temperature will continue to rise. However, it's up to us to control how much it rises. Well, that's all the time I have for today, but if you have any more climate questions, I implore you to ask. Bye!